Hello, welcome to video presentation for assignment 2 on component based software development SWE 645. This presentation will include Spring Boot backend application, containerization with Docker, setting up Kubernetes cluster with Rancher, setting up continuous integration and continuous deployment with Jenkins, and lastly end-to-end demonstration. This is our Spring Boot application. It contains two files, index.html and 404.html present inside resource static directory. Index.html will display the survey form, whereas 404.html will display the error page in case of any exception or incorrect URL. IndexController.java file is the Spring Controller class and it is annotated with @REST control annotation. It has two methods, getIndexPage method and getErrorPage method. GetIndexPage method is annotated with @getMapping, maps HTTP GET request to the root of web application to this method. It specifies that the response content type is media type text HTML value, indicating that this method return HTML content where class path resource pointing to resource static index.html. The content of HTML file is read by using stream util.copy to string method and return response entity object of HTTP status of HTTP status code 202 and HTML content as the response body. GetErrorPage method is similar to getIndexPage but mapped to handle all other paths using the wildcard, intended to display a custom 404 error page. It load and return the content of static 404.html as response body with the HTTP status code 404 to indicate that the requested resources are not found. Now coming to a Docker file. Docker file defines the step to create Docker image for Java web application, utilizing a two-stage build process to complete the package the application with Maven. Then it run on a lightweight Java runtime environment. First stage, building the application. From this line, start the first stage of build using the latest Maven image as base. This line sets the working directory inside Docker image to web app. All subsequent commands will be run from this directory. This line copies the source code from host machine into web app directory inside Docker image. This line execute the Maven clean goal, and the next line, which is run Maven install, run the Maven install goal, which compile the application's source code and package into jar file in the target directory. Now in the second stage, which is the running the application, this line initiate the second stage using Amazon Caret 17 based Alpine Linux 3.19 as a base image. Now this line copies the jar file built in the first stage from builder image from web app target directory to the root of the new stage, renaming it to app.jar. Now this line, which is expose 8080, inform Docker that the container listen on port 8080 at runtime. Now this line, which is run ls-la, this command list file in the current directory along with their permission, sizes and modification date. Now in the last line, it start the Java application package in app.jar using Java runtime. Now my teammate will explain cluster setup.
So we are using Rancher and EC2 instance for setting up the Kubernetes cluster. So we have three EC2 instances running in our AWS Academy. One of the instance, as you can see that I have named them, we are using for Jenkins and Rancher. This is Rancher local cluster. And for the Spring Boot application, we have a master node, and then we are using the other two nodes as worker nodes. All of this I will show you in the Rancher UI. So as you can see in the Rancher UI, we have two active clusters running. One is the local cluster and one is the Spring Boot web app cluster. So our application is deployed in the web app cluster. So if I go into the web app cluster, you can see we have three nodes here and we have tried some previous deployments. So if we go to the nodes, we can see that we have two worker nodes and one master node. We'll use this cluster to deploy all our pods and run them and serve our survey page application. So you can see the deployment.yml file. I'll describe about the deployment.yml and service.yml file that we are using. In the deployment.yml file, there are a couple of things. So the name of this deployment is deploy Spring App, and the image it takes is image name and build timestamp. This will be built on the Jenkins with appropriate image name and timestamp, and it will be sent to Docker Hub. So what this deployment file is doing, it's just pulling the respective image that is being built by the Jenkins pipeline, and it's listening on port 8080. And if you see the strategy, deployment strategy, I'm using rolling update and with a max surge of 1 and max available of 1, because I want my application to be available even while deployment is ongoing, right? And the number of replicas, I'm using 5 because the assignment says we have to use at least 3 pods for the deployment. And for the service YAML file, we are using this of kind node port, and then we are mapping it to the target container port and the target node port. So this is the service file that will be routing traffic to all the ports which matches this label. This is like an overview of deployment and service YAML file. Further, the CI/CD setup will be explained by my teammate.
So this is the Jenkins file. Now I will go through the Jenkins file of what we have done. So first of all, we will give the environment variables. We give the credentials to login and get the Docker image. After that, we check out the code from the GitHub repository and we include the Jenkins files at the checkout step. Now we will build and deploy a survey page. In the script, we have written some codes. So first of all, we will print the image name and build the timestamp for debugging purposes. After that, we log in into the Docker registry using the credentials that we have stored in the Jenkins. Then we build the Docker image with a tag based on the build timestamp. After that, we push the image to the Docker registry, and then we will remove the local copy of the built image in order to save the space. After that, we apply the Kubernetes services configuration, and then using the environment substitute variable, we use it to substitute the environment variable in deployment.yml, and then we apply the deployment configurations using the deployment resolved YAML file. And then we copy the deployment resolved YAML file and then run the service. Now I will show you the Jenkins UI. So this is the Jenkins UI. This is the dashboard of Jenkins. We have already logged in. So we will first show you that where we have stored the credentials. We have the credentials stored in here. This is the Docker and this is the GitHub credentials. This is the pipeline that we have created. We have already built our file over here, and then we have already deployed our application.
Okay, so I will show you a end-to-end demonstration of how this whole setup works. So first I will do is I will change the readme.md file. I'll just give a space in this readme.md file, which will trigger the Jenkins continuous integration pipeline. So as you can see, I have added some space in the readme.md file. And now what I will do is I will go and commit this file. So as you can see, I can show you git status. So this is the readme.file that has changed. I will do git add to add the configuration. Now you can see the git file is added. So I'll commit this file given a name, and then I will just push the file to the master branch. So I'm just waiting for the Jenkins CI to run, because it checks the master branch every 1 minute. Based on the last time it has checked, it might take 1 minute. So as you can see, it has already detected the changes in my last push, and it started to run the continuous integration pipeline. As you can see, the pipeline is running and it will go through all the steps that we have defined in the Jenkins file. So I'm just waiting for the CI to complete and deploy the application to the Kubernetes cluster. So as you can see, our CI/CD is complete. So let's go and check if it has successfully deployed the application. So in our deployment file, we are maintaining five replicas. So you can see we have 5 replicas over here. So let's go to the command line and check if 5 replicas are running. As you can see, 5 replicas are running, and it started running before 40 seconds, which is our last deployment. So let's move ahead and check if the website is running. So let's go to the rancher and the cluster. And you can see in the last deployment, we have 5 pods running. So this is our UI where we have loaded multiple times. So this is the UI that is deployed that we have, which is running on the rancher cluster. So this is like the end-to-end demonstration of our homework 2 for 645 assignment. Thank you for watching the video.